Hi there, this is Robin Andrews from Compt Academy, where we teach you about programming and computer science in a fun and accessible way. Now, today, it's not hugely technical. I'm going to talk about whiteboards and why they are so incredibly useful. So back in the day, the ancient Greeks used to do their geometry in the sand, and the tide would come in and wash away their sketches. Now, that was actually quite a good method because you could just scribble. And I think it's quite important to understand that there's kind of two types of writing, really, in the way I see it. You've got very precise, very measured, deliberate writing where you're kind of, maybe focusing on presentation and detail. And you've also got just like exploratory, like marks. Okay, so you're in the sand, you're just kind of moving your finger, seeing what happens, yeah, making patterns and squiggles. And there's an equivalent process with thinking. If you too quickly try and get your thinking to be very, very ordered and structured, then there's a danger that you don't activate the creative juices of your brain so much. Sometimes it's good to just kind of have a slightly looser approach to what you're doing. And that all sounds very abstract, but it kind of makes sense. And that's why whiteboards are so good. You can scribble on them. Okay, wonderful stuff. However, there's a couple of other advantages. So with pen and paper, which was like the prevalent technology for a good long time before they invented these things, right? It's great because if you have a pencil in particular rather than a pen, you can rub out your markings and you can overwrite them. But it's not nearly as easy as it is with this. So I'm just going to give you a little example of something. Say I'm trying to explore an algorithm. I'm just going to make my marks and I'll show you in a minute. Okay, now sometimes if I'm actually teaching using this, I have like a little, it's actually a recipe book holder on my desk, and I point another webcam at it. But for the purposes of this video, I'm not going to do that, so I'm just going to get confusing with moving stuff around. So what I've got here is it's actually a grid representation, 2D matrix, and these are my indices, okay? And what I'm going to try and do is work out how depth first search works. Now, you don't need to worry about the content of what I'm doing here. It's really the process that matters, okay? So depth first search requires the use of a stack, so I'm going to create a stack. So that's my stack. I'm not even going to bother closing it off because I might want to change it later on, okay? So it really is like scribbling, but this is where the understanding, okay, the understanding comes in a kind of messy way, almost like the tide coming in. It just splashes where it splashes and goes where it goes, like water finding its own level. So we don't need to worry about precision here. Later on, we can tidy things up. Okay, so I also have a list of visited nodes, so I'm going to have that over here. So just go to V over here. And actually, I'm going to start off with my first node having been visited. Now you can see here, I've actually just used I mean, my handwriting is really messy. Okay, that's just partly being left-handed, partly just the way I am. So don't worry about that. That doesn't matter. You can see here that I'm not having to be really precise. I've used 0, 0. I haven't done like a tuple with an open bracket and a closed bracket and a comma and the right spacing inside, and then done 0, 0. I've just, because my purposes are understanding rather than communication at this point. Okay. Then I've just done 0, 0, 0, 1 for my indices. Remember, we've got row, and then column, okay, with 2D lists, if you know about that stuff. If not, don't worry about it. So then what am I going to do? I'm going to visit my first node by popping my stack. So I'm just going to put a circle around my 0, 0, and then get rid of it there. I can just rub it out with my finger. Could get one of these nice whiteboards if you want, but why not use your finger? So now my stack is empty, okay? But I need to push my neighbors onto my stack. So my neighbors are 0, 1, and 1, 0. Okay. And let's say, okay, I didn't even mention, let's say this is my goal here. Okay, I want to get to this square here. So 0, 0 wasn't the one I wanted, so I have to carry on. So next, what do? I pop my stack, so that means I'm checking 1, 0. Okay, that's 1, 0 here, so I've visited that. And then it's not what I'm looking for, so not on cue, I push my neighbor. So I do, I didn't remove that, so I have to remove that one. So then I do 1, 1, and then 2, 0. Okay, and it goes on. And it's the point of this video really isn't about the algorithm. It's about how, if you're trying to understand a process, like quite a complex algorithmic process, then it's quite a good idea to use a whiteboard. Basically, I'll give you another example, a more simple example actually. I was doing a video earlier on today about a game I was writing called Leapfrog, and it looks a bit like Hangman. So you have like, I'll just do this quickly. You have like A, B, B. Okay, so basically you've got to get all your A's across to the other side, or your B's across to the other side, and you're only allowed to move one spot to the side either way, or you can leapfrog. So it's actually quite difficult to kind of trace that in your head, and even on paper it would be quite a faff. But what you can do is I can say, well, I want to move that across. Okay, so that's going to go to here. Okay, and then my B here, I want to leapfrog that. That's going to go to here. And again, all I've got to do is rub the stuff out. Yeah. Whereas, you know, if you were doing this on paper and you had to cross it out, then it'd be really hard to see what was meant to be kept and what had been crossed out. I suppose you could have, like, you know, lots of entries going down the page, maybe vertically, and then you'd be working on the current one. That would be one solution, but nothing like as kind of fluent and fluid as using a whiteboard. Okay. One more example you might want to use, just because I was doing it this week with some students, I was doing Dijkstra's algorithm. So I had a graph, like boom, 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 and it was all joined up in various ways with various weights. Okay. And then I had a table on this side. So my table was my vertices, my minimum distance, and it was my predecessor, I think. Okay. And then I had a table, and I had my vertices, VE. And then we had lists. So we had this was A, B, C, D, E, and this was maybe some weights like 1, 5, 5, 2. I don't know what the numbers were, obviously, can't remember. But then I had my visited and my unvisited. And unvisited was a set, so I had the square squiggles. Started off with them all unvisited, A, B, C, D, E. And then as soon as I wanted to move one from my, you probably can't see that actually. As soon as I wanted to move one, you know, from my unvisited to my visited, I could just rub it out. Okay. They're meant to be curly braces, by the way, for sets. Okay, so it was as easy as that. But also another thing, I needed to check the neighbors for the current one. So I had this like neighbors entry. Okay, so my neighbors for A were D and whatever I've written there. Sorry, that's a B. So they were B and C. So for this particular pass through the algorithm, it was B and C. However, on the next pass, it was going to be different. So I could just cut them out. So I think you get the idea. It's a surprisingly useful tool when you're trying to actually understand how algorithms work. And there's this whole thing with CS unplugged, okay, which is computer science away from a computer. And this is a great way of exploring some of these algorithmic concepts, some of this algorithmic thinking and problem solving skills without actually writing code. And then when you come to actually write your code, you've got all of this experience, you've got all the kind of, you know, pathways have started to be, you know, kind of, what's the word, kind of carved out in your brain. You've kind of got those neural pathways initiated. So when you're, you know, thinking about the details of the algorithm in terms of coding, you've got this experience to fall back on. So that's another good reason to work away from the computer. Slightly different point to what I'm making about the medium that you use. But my point is, whiteboards rule. Yes. Okay, so that's it for now. Hope you found that useful. I'll see you in the next video.